Hi, class. I'd like to continue where we left off Tuesday. This was the last example I had done in the notes. And I had these two answers, m equals 3 and m equals 11. So I just wanted to, um, I forgot to check to see if any of these answers were extraneous. And so I noticed that when I looked at this again. So let's take these two answers and let's check them. Okay, so let's start with m equals 3. Okay, so let's check that answer. So if we want to check this answer, we put it back into the original question. So there was the original question at the top. Okay, so we put that back in, and so we've got 3 minus 2 times 3 plus 3 equal to 6. Okay, and so we have 3 minus 6 plus 3 equal to 6. And so we have 3 minus the square root of 9 equal to 6. Okay, now we know the square root of 9 can either be negative 3 or positive 3. When we're doing radical equations, it only allows for the positive possibility. Okay, so basically what that means is this is going to be 3 minus 3 equal to 6, or 0 equal to 6, which is not true. So m equals 3 would then be what we called extraneous. Okay, so extraneous means that it's not a possible answer. Okay, and I should have mentioned that Tuesday, so I apologize for that. Okay, so that's an extraneous solution. So again, when you're substituting back in with radical equations, it only allows for the positive possibility to come out of the root. Okay, let's check m equals 11. Okay, so m equals 11. So we check that one. We put that in. So we got 11 minus the square root of 2 times 11 plus 3. So we have 11 minus 22 plus 3 equal to 6. And so this is going to be 11 minus square root of 25 equal to 6. So 11 minus 5 equal to 6. So 6 equal to 6. Okay, so that one is going to check out. Okay, so your only solution to this question here is m equals 11. Okay, so again, my apologies for not pointing that out last class, and I think that would have led you to some problems perhaps with the homework that I had assigned. So I was really happy to see I got a lot of questions that you had wanted me to go over. So what I'm going to do tonight is go over the questions that you had problems with from before the break and last class, and then I'll assign some review questions for you to work on. Okay, and then what I'll do on Tuesday's class is I'll begin the next section, and I'll also give you a take-home test. Okay, so a take-home test for chapter 5. So open book take-home test. So you can do that using your notes and your textbook, and then you basically submit it back to me, and then I'll mark that. And also just while I'm talking about tests, I have the test marked from before the holidays. Okay, so if you want to find out what you got on your last exam, just send me a private chat or a email, and then I can just let you know what your score was. Okay. All right. So let's look at the answers to the indicated homework questions you wanted me to go over. Okay, and so we'll start with 289. Okay, so this was before the break. We had done this. So the first one here. So remember, this is a cube root. So you can't pull the 4 out. If it was a square root, you could pull the 4 out as a 2, but you can't here. Now this is the cube root of 8, which is, this would be considered a perfect cube. So the cube root of 8 is going to be 2. Okay, so then you have the 2 in front times 2, which equals 4. So we can put that back into the brackets, 12 plus 4, which is going to be 16. Okay, and then you can multiply that by the cube root of 4k. So we get this answer here, 3 minus the 16, the cube root of 4k. All right, you can't put these two together, so you just leave it like that. 4e. Okay, so here you can't put any of the stuff that's inside the second bracket together, and you can't put any of the stuff in the first bracket together. So you leave it as is. So this is our expanding. So first thing we're doing is we're multiplying negative root 6 by everything, and then we're doing the same thing with the 2, right? So 2 is going to multiply the first term, the second term, and the third term. Okay, so you get this big whole thing. What you want to do when you do these type of questions is you want to look to see, are any of the roots, are you able to simplify? So you can't simplify the 5, you can't simplify 2, you can't simplify 6, you can't simplify 30, but you can simplify 12 because the perfect square exists in there, which is 4. 4 times 3 is 12, and so we can take the 4 out as a 2, right? So that comes out as a 2, and then multiply by the 2 in front, so that gives you negative 4. All these things are different, so they're all unlike terms, therefore they cannot be put together. Okay, so you leave it like that. Okay, 4D, this was an interesting question. What you have here, I think the question was, it was just one bracket squared, so if it's squared, that means you're multiplying it by itself. Now the thing is, you've got a cube root and a square root. So remember what we talked about is when you're multiplying roots, you multiply what's in the inside. That's only if they're the same. So in this case here, you cannot, when we go the cube root of 2, 6, and the cube root of 2 multiplied by 4 root 13, the 2 and the 13 can't multiply together because the roots are different. Okay, so if they're both cube roots or both square roots, then you could do that. Okay, so that's why you kind of get this weird answer over here. Okay, then we so these were the multiplication type questions, and then we had questions having to do with the rationalizing the denominator. So remember, rationalizing the denominator is when you're trying to remove a radical from the bottom. Okay, so the first one here. Okay, so now this format I think confused some people. If it's like this, you can break it into two separate radicals. So see what I did there? The 5 and the root 12u, right? So you can take that apart, just the same thing as like if you're multiplying. So what we've got here is we've got this 12 on the bottom, which we can simplify by pulling out a 4, which becomes a 2. So 2 times 3 is 6. And now what you can do is you can, when we rationalize the denominator, what we're saying is we don't want that a radical at the bottom, so that 3u. So to get rid of it, you have to multiply both of these by 3u. Okay, so remember, if we're multiply the bottom by 3u, root of 3u, we have to do that to the top as well. Okay, and so that's what you end up getting. And so just in terms of of restrictions, just going back to the original question, here u has to be can equal 0 for this one, okay, and it can't be negative either because then you have a negative root, and then over here u can't be equal 0 also, okay, and then this one can't be negative, right? So just going back to the restrictions there. Okay, next one here, 8D. So same idea. This time, now this one's a little bit different. It's a cube root, right? So if it's a cube root, we've got, so same idea. I can break this into two, right? The top and the bottom. But notice here, if I want to get rid of a radical that's a square root, I have to multiply it by itself. If it's a cube root, I have to multiply it twice, right? Because three cube roots basically get rid of the cube root, right? And so square root you're multiplying twice, cube root you're multiplying three times. If it was a fourth root, you'd be multiplying four times. Okay, so that's why I'm multiplying with the cube root of 5, cube root of 5. Okay? Cube root of 5, cube root of 5. Same on the top and the bottom. And so that gets rid of that. So when you got cube root of 5 times the cube root of 5 times the cube root of 5, that's going to be the cube root of 125, which is just going to be 5. Okay, and then on the top you're multiplying 6t by 5 by 5, so that gives you the 150, and then the 20 over 5 gives you 4. Okay, and make sure when you do these questions, make sure you keep the 3 in, just to indicate it's a cube root. Don't get rid of that 3, because then it looks like it's a square root. Okay, number 10, so same thing, we're going to rationalize the denominator. Remember what we call this thing when we want to multiply here. You notice how this is minus root 3, this is plus root 3. This is what we call the conjugate. And again, the reason why we multiply by the conjugate and have that opposite sign is that always allows for no radicals to be present. Like if you expand that, you'll see what I mean. So here you get 10 plus 5 root 3. Okay, so it's 5 times 2, 5 times root 3. And then here you're going to get 4 minus 3, which is just going to be 1. Okay, so you get 10 plus 5 root 3. Okay, and then 11b, same idea, conjugate, so root 6 plus 8, root 6 minus 8. So these signs are always going to be the opposite. Okay, so again, that's what we mean by the conjugate. And so that'll be 6 minus 64. And then you can simplify it, and that's your final answer. Okay, number 10, same thing. We've got root 3 minus root 13, so it's going to be root 3 plus 13, root 13. Okay, and then number 11, this one, just be careful with, the r is not inside the root, okay, so that's outside the root, so it's just root 6 multiplied by r. You could always stick the r in front of the root 6 if you want, if that's a little, it's easier to see that it's not in the root that way. So again, conjugate is root 6 r minus 9, okay, so the opposite sign. And so that's going to give you 6, and then r squared, so that's squared because it wasn't in the root, and then minus 81. Okay, now page 300, so this was the solving equations, and so I can understand the difficulty you might have had with determining whether or not a root was extraneous, so that's what number 5 basically looks at. So they basically say here's the, they give you two possible answers, x equals negative 8, and k equals negative 8 and k equals negative 2, and then they're asking you, are any of these extraneous? Okay, so if we look at k equals negative 2, so we got negative 2 plus 4, right? So we substitute it back in, that's going to give you 2. And then in the root here, you got negative 2 times negative 2, which is 4. Square root of 4 is 2. So again, when we do the radical equations, what we work off of is that the only possibility is the root's going to be positive. Okay, so this then holds true. If we try k equals negative 8, we got negative 8 plus 4, which is negative 4. And then we got negative 2 times negative 8, which is 16. Square root of 16 is going to be positive 4. Okay, so again, we're only taking the positive case, therefore this becomes what we call extraneous, because you can't get these two to equal out. Okay, so I know there's a little bit of confusion with that, because you could argue, well, isn't a square root could be positive or negative? That is true, but for the radical equations, we only consider the positive case. Okay, so and that's what we call the real number system. Okay, so extraneous. Okay, so again, extraneous means that you can't get the two sides to work, or an answer violates a restriction. Okay, and so that'll lead us to a bunch of extraneous answers on some of the questions here. So this is the way we go about solving. So I've got this -7. I move over to this side, so it becomes +7. That gives you 24. And I've got the -4 in front on this radical. So we divide both sides by -4 to get rid of that. So we get -6. Okay, when you want to remove a radical, you square it. So we square this one, we square this one. We get 2x minus 1 equals 36. And we get x equals 37 over 2. So if we put that in, what's going to happen is you're going to multiply this, and you're going to get 36 inside the root, which is going to be 6. And then -7 minus 24 is -31. Okay, which doesn't equal 17. So because that's extraneous and that's the only answer you got, this would have no solution. Okay, so there'd be no solution for this question. Okay, 7c. So here you've got radical q squared over 2 plus 11. So square that, square the q minus 1. Okay, and so that gives you this whole thing. We want to get rid of the 2. We can multiply the q squared over 2, get rid of that 2. We can multiply everything by 2. So that's going to give us q squared equal to 2q squared minus 4q minus 20. And then the q squareds can go together. So that gives you q squared minus 4q minus 20 equal to 0. So try to factor that. If you're having a hard time with the factoring, you can't think of how that would work out, or if it's too difficult, then use the quadratic formula. Okay, so -b plus or minus b squared over minus 4ac over 2a. Put all that in, and you get 2 plus or minus 2 root 6. Okay, so I'm not going to check for every one of these if they're extraneous, but I mean that's what you would want to do. Just put it in and see if it's extraneous or not. Okay, 7d, same thing. We've got to expand both sides, square both sides, and then expand them. Okay, so what you want to do first is you want to get rid of this 2 and put it on this side. That'll make it a little bit easier, and then you can divide, because everything is divisible by 2, you can divide everything by 2. And so you get 7 minus n, so square that, square this side to get rid of the radical, n squared minus 7, and then here's this side, and we get n equal to 4, right? Again, put that in to make sure it's not extraneous. Okay, 8a, so same thing here. So now we end up with a quadratic. So just to recall with the quadratic, we want we want to factor this. So we want two numbers that add up to minus 13 and multiply to 30. So that'll be -10 and -3. And so you work that out to x minus 3, x minus 10. So you get two answers here, 10 and 3. And if you put the 3 in, it's going to be extraneous. Okay, so your only solution then is x equal to 10. Okay, so this is not an answer then. Okay, so again, put that in, and you'll see it doesn't work out. Okay, same thing with 8c. You square both sides. You factor. You get d plus 1, d minus 4. So you've got -1 and 4. And the -1 is going to be extraneous. Okay, so again, to determine it's extraneous, you put that back in. And again, you're only considering positive roots to come out. And so that because of only the positive roots, it doesn't work out. Okay, 8D. This one's, we want to move the 5j over to this side, so that's why it becomes negative 2j minus 1. We square both sides. And then you get j plus 1 over 3. So you want to get rid of that 3. You multiply everything by 3. Okay, and then you collect it all. And so again, with the factoring here, you've got two numbers that add up to 11 and multiply to 24. So 24 is 12 times 2, right? So that's where the 24 comes from. Remember the A times C. And so that's going to be 8 and 3. And so here's what you end up getting after you factor it. 4j plus 1. So here j would equal negative 1 over 4, right? That'll make that 0. And then the other one here is 3j plus 2, so that'd be negative 2/3 j. So same thing, you get two answers. One of these is extraneous. Okay, so this one is not an answer. Okay, next one here. So again, just to go back to this one, when we say an answer is extraneous, that means after you can only determine that after you put that back in. Sometimes you'll be able to look at it and you can see it won't work out, but to determine if it's extraneous, you basically put it back in, and then because you're only allowing for positive roots to come out, then this answer, when put back in, won't allow for that. So that's why it's extraneous. Okay, 9b, square both sides. You get negative 3m equals negative 7m, so the only possible answer here is m equals 0. Okay, 9c. So this one, what you can do first is you can simplify this root at 200, so that's 100 times 2. So take the 100's a perfect square, so that gives you 10 root 2. And then you can, there's a 5 there and a 10 there, so you can just make this a 2, divide both sides by 5. And so square it, so you get j over 2 equals 8. So j is going to equal 16. Okay, last one here. So this one is a fairly lengthy one, so you've got 5 squared equals 3n minus n, with root of 3n minus root of n. Okay, so you can't just subtract these. I know you see n's in both of them, but they have to be exactly the same inside. Okay, so we square both sides, 25, and then we're going to square this one, and so that's going to give us 4n minus n root 3 and n root 3, which is going to give us 4n minus 2n over root 3. Okay, so if we factor the n out, that leaves us 4 minus 2 root 3, and then so divide both sides by that to isolate the n. You get this answer here. Okay, so you might have gone with this as your final answer and then looked in the back of the book and said, why isn't that not there? So again, radicals always are must be rationalized. Okay, so this one, because you have the radical on the bottom, it's not in the rationalized form, so you have to rationalize the denominator, and so that's where you multiply by the conjugate, and after you multiply it by the conjugate, that'll get you the final answer here. Okay, so I'll stop there. So you can work on these questions here for chapter 5. Okay, so this is the chapter 5 review. Okay, so do those, and then again, send me any questions that you have from these, and I'll go over these. So I can start Tuesday's class by going over these answers first, and then I'll give you the first section of the next unit, and then I'll also have an attachment of the take-home test. Okay, so you can do the take-home test at home, and again, that'll be an open book test, and then you can submit that back to me. So hopefully you're getting fairly comfortable with the Teams app. If you still have questions regarding how to use it, just let me know. These questions you don't need to submit and show me. Okay, so the first thing that I'll get you to submit will be that take-home test. Okay, so again, let's let's ask lots of questions. I know this is a difficult format to be learning. It's not the ideal format. There's no sort of one-on-one interaction that is more useful. In-person instruction is always better than this type of format. So do your best. Try the questions out. Again, just let me know which ones you're having difficulty with, and we'll look that over. Okay. So again, stay safe. Look after yourself. Look after the people around you, and just keep submitting questions that you have. All right. Okay. Take care. Bye.